Hey everybody, welcome back to another fun and exciting geometry class. Today we're going to be talking about parallel lines. This lesson is found on page 67 in your book. It's 2.9, and so let's go ahead and get started. If you look down at the page in the book, you'll see some different things. It talks about, basically, it defines what a parallel line is. And I think most of us at this point in our career here in geometry class, we have an idea what those mean. And if you don't, it means that they never intersect. They never cross each other. Parallel lines just go in the same direction, and they never cross each other. If you look down there on page number 67, it talks about the parallel postulate, postulate number 6. Now, we're going to use this one a lot. You're going to see this one continue to come up in your proofs as we go through the rest of the book. So make sure you pay special attention to this one. What it says is the parallel postulate says that through a given point, one and only one straight line can be drawn parallel to another line. If you look down here on the screen, I've got a line. This line is a straight line, and then there is a dot underneath the line. I can only draw one parallel line through that point. In other words, I can only make that line parallel. I'm going to pretend like that went through the line. But you can only draw one parallel line through that point right there. Any other line that you try to draw through that point is not going to be parallel. At some point, that line is going to cross. Even if it's something very slight, at some point, that blue line is going to touch this other lighter blue line. Now, it might continue to go for a long time and way off the screen, and you might not see it cross, but it will cross. Why will it cross? Because it's not exactly parallel. So you can, through a point off the line, you can only draw one parallel line through that point. We've already talked about this, but you can also only draw one perpendicular line through that point. Okay, and so one parallel, if I could actually get it to work, that's going to be close enough. You can only draw one perpendicular. We've already had that one. Now we're at this one where you can only draw one parallel line through the point. So that's postulate number 6. Look down, postulate number 6, corollary 1. Says that if two straight lines are parallel to a third straight line, then they are parallel to each other. So that's this right here. If I've got 3 lines and I say, okay, A is parallel with C. A is parallel with C. So basically this line is parallel with this line. Okay? And then I say B is parallel to C. So I say B is also parallel to C. Then by deduction, we could prove that A is also parallel to B. Why? Because A is parallel to C and B is parallel to C. And so that means that A must be parallel to B. There's no other options there. All right, so that is postulate 6, corollary 1. If you look down on the page 67 at the bottom, it uses the word transversal. This is an extremely important word. We have to know this word, or else when you hear me say it over and over this year, because I will say it a lot, you're going to go, what's a transversal? So you need to learn this word. Super, super important. A transversal is a line that intersects 2 or more lines. A transversal is a line that intersects or crosses 2 or more lines. Look down here at this example. You will see that I have a line right here, this blue line, and it is crossing 2 lines. Now, you could have even more lines that it crosses, but for sake of the illustration, I made that blue line cross the green line and cross the yellow line. Now, what does that mean? That means that that light blue line is a transversal line. It transverses 2 different lines. So it's a transversal line. Very, very important that you know that. Now let's talk about some things with the transversal line. These are going to be very important for you. So let's try to pay attention here as we go through these different things. The first thing, 1, 4, 6, and 7 are interior angles. So look at this 1, 4, 6, and 7. Those are interior. Why? Because they're on the inside. Okay? They're interior. Very important that you understand that concept. Well, then obviously 2, 3, and 5, 8, they would be what's called, if you look down here, those are exterior angles. Okay, exterior angles. Why? Because they're on the exterior. They're on the outside of the lines. Okay, so interior and exterior. Very important that you understand that. 1, 4, 6, 7, interior. 2, 3, 5, 8, exterior. All right, next thing it says here is 4 and 6 and 1 and 7 are alternate interior angles. Interesting. Let's look at that again. 4 and 6. All right, 4 and 6 are what's called alternate interior. Well, they're both interior, okay? But look, they're on the alternating side of the line. Of what line? Of the transversal line. What's the transversal line? It's this blue line. So they're on alternating sides of the transversal. Well, then you would also have to say that 1 and 7 are alternating interior angles. Okay? They're alternating interior angles. All right. Well, that would mean then, by logical deduction, that 2 and 8 would be alternate exterior. Why? Because this is exterior, and they're on alternating sides of that transversal line. Well, then, of course, by deduction, we would know that 3 and 5 are also alternating exterior. Alternating exterior. So make sure you know those. Those are there in your book. So 2 and 8 and 3 and 5 are alternating exteriors. And that's on the bottom of page 67. All right. Now the next thing is 1 and 3, 2 and 4, 5 and 7, 6 and 8 are all what's called opposite angles. We've already talked about opposite angles. We could also call those vertical angles. Vertical. Okay. So what does that mean? 1 and 3 are vertical angles. We know something else about those because we know about vertical angles. We've already studied those. What do we know about vertical angles? Okay. 1 equals 3. Maybe that's the first time in math you've ever seen that 1 equals 3. Now, I should have written angle 1 equals angle 3, okay? So don't want to confuse you. Angle 1 equals angle 3. 1 does not equal 3, by the way. Angle 1 equals angle 3. Why? In a proof, let's say we're doing a proof. Why? What's the reason? Because they are vertical angles, and vertical angles are equal. Well, what other ones are equal? Well, 2 and 4. Angle 2 equals angle 4. So that's interesting. Down here, we would have 5 and 7. Angle 5 equals angle 7. And then we would have 6 and 8. Angle 6 equals angle 8. And those would be the vertical angles that are found there on the transversal lines. Okay. I think that's it right there. All right, if you go ahead and turn the page over to page 68, 2.10, proving lines parallel. How are we going to prove that those lines are parallel? Let me get rid of that pink line first. So we have the green line and the yellow line. How are we going to prove? Now, you say, because they look parallel. What if they're a half of a tenth of a degree off? I mean, they're just so slightly off. They're just almost parallel. Your eyes would never be able to see that. But how can we prove? What is a way that we can prove? Well, theorem number 7 helps us. when two straight lines are cut by a transversal. So let's go ahead and cut these two lines with a transversal. Let me make it a straight line. That will be better. So there's my transversal. And I can make it be whatever I want to make it. Okay, a transversal can be perpendicular. A transversal could be this way. Okay, the transversal just has to cut the two. It doesn't matter how we draw the transversal. Okay, so as long as it cuts the two lines. If a pair of alternate interior angles are equal, then the two straight lines are parallel. So, in other words, if we go around this thing, 1, 2, 3, 4, I think this is how this one went, 5, 6, 7, 8. Okay? I think that's basically how the other one was numbered. If we can prove, whichever one, it doesn't matter, any set of alternate interior angles. So here's an interior angle. 4, and what's its alternate angle? Alternate interior, 6, because it's on the opposite side of the pink line, of the transversal line. So 4 and 6. If we could prove that angle 4 is equal to angle 6, if we could prove that, we would prove that these lines, the green line and the yellow line, are parallel to each other. Okay, that's what theorem number 7 says. When two straight lines are cut by a transversal, if a pair, any pair, of alternate interior angles are equal, then the two straight lines are parallel. Okay, so if we can prove 4 and 6, we could also prove what other ones? We could also prove 3 is equal to 5. If we can do that, then we would know that those are parallel lines. Okay. If you look over on page number 69, it kind of goes through an analysis of the proof there and talks about how that's done. We won't take the time to go through it, but just suffice it to say that that is true. If they are alternate interior angles and they're equal, lines are parallel. Corollary 7. When two straight lines are cut by a transversal, that's what we have here, if two corresponding angles are equal, then the two straight lines are equal. Corresponding, what does that mean? Okay, well, in corresponding in triangles, that meant when we moved the thing on top of each other. So if you can think, what if I cut out this line? Okay, so I cut it out and I moved it down to the other line. So I basically moved it down, and so those angles sat on top of each other. So let's talk about what a corresponding angle is here. Which angle corresponds with angle 1? If you're thinking, okay, I'm moving this, boop, 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 boop. Which angle is number 1 going to sit on top of? 1 and 5 are corresponding. We can write that down. Angle 1 corresponds, I'll just write that, cors, with angle 5. Corresponds. Change the color here, and I will say angle 2 corresponds with angle 6. Angle 2 corresponds to angle 6. Change the color again, and we'll go to angle 3. Angle 3 corresponds with angle 7. You got it? So angle 3 corresponds to angle 7. And then obviously there's only one set left, and that would be angle 4 corresponds with angle 8. Okay? And that basically goes through all the corresponding angles that could be possible. So now that we kind of know what corresponding angles are, let's go back and let's look at the corollary 7.1 again. It says, when two straight angles are cut by a transversal, if two corresponding angles are equal, then the two straight lines are parallel. So, if I could prove that 1 and 5 are equal, so if I get angle 1 equals angle 5, if I get that, then I prove parallel lines. Okay, so let's put if that, then parallel. It looks like 11, I know, but it's parallel. And usually the parallel signs are close together so you don't get them confused by, with an 11. But parallel is just two sticks right next to each other, just like the number 11, basically. Okay, so if 1 equals 5, why does 1 equal 5? I don't know. We proved it a different way. Maybe it was in the given. Maybe they told us. We don't know. I'm just saying, if that's true, if angle 1 equals angle 5, then the lines are parallel. I'll just do these other two corollaries quick. My time is fleeting very rapidly. Corollary 7.2. Two lines perpendicular to the same straight line are parallel. Okay, so if I have a perpendicular line, so two lines perpendicular, so if I have a line here and a line here, and they are perpendicular to the same line, what does that mean? Well, perpendicular means that they have 90-degree angles. So one way that I could do it, these are corresponding. That is corresponding to that. So if I could prove that those are right angles, then I prove that everything is perpendicular. That's a perpendicular. And the other thing is that that is parallel. So by proving right angles, I prove perpendicular and I prove parallel at the same time. And that's corollary 7.2. Corollary 7.3 says, when two straight lines are cut by a transversal, if the sum of the two interior angles on the same side of the transversal is equal to a straight angle, then the two are parallel. So what does that mean? Well, if I have a parallel, if I have lines that I'm trying to prove parallel, and they're being cut by this transversal, okay, if I can prove that it says that the sum of two interior angles, okay, so if I can prove, let's call this 1, 2, 3, and 4. So if I can prove, let's go 5, 6, 7, 8 right there. Two interior angles. So if I can prove that 3 and 5, it doesn't say alternate interiors. It just says two interiors. So 3 and 5. Alternate interiors would be 3 and 6. But if I can prove that 3 and 5 equals 180, or a straight angle, then I also prove that those are parallel. So that's another way to do it. So if angle 3 plus angle 5 equals 180, or a straight angle, then parallel. Okay. So if angle 3 plus angle 5, or 4 and 6, that would work too. So we could go over to these ones. 4 and 6 would also work because those are the other interior angles. If they equal 180, then you would get parallel. We'll talk more about that later, and that's an interesting one right there. We're gonna connect all this stuff together, and I know maybe that's a little bit of overload today, but I wanted to get all of that information in there to you so that you could be ready for it. Okay, if you missed anything, make sure you go back there, rewind it, take a look, watch it again, and check it out. All right, we'll see you later. Have a good one. Bye-bye.